For decades, dietary dogma has basically told you that if you want, like, elite muscle-building protein, you absolutely need chicken breast.
Right, or steak, or a dozen egg whites.
Exactly. But biochemically speaking, a cheap peanut butter sandwich on whole wheat bread, or even just a really simple bowl of rice and beans, can quietly rival that steak.
Yeah, it's honestly wild how close they are.
Right. So today we are unpacking why the whole concept of incomplete plant protein is just, well, scientifically obsolete.
It really is. It's completely outdated.
So we are diving into a comprehensive nutritional guide and some really fascinating recent research to understand how your body actually processes plant foods.
And how to bypass those bottlenecks of digestion.
Yeah, and why engineering the perfect macro plate is probably doing you more harm than good at this point. Okay, let's unpack this because the persistence of this myth is just crazy to me.
Well, the persistence of this incomplete protein myth, it really highlights a fundamental misunderstanding of human digestion. We tend to view food as static math, Like you eat 20 grams of protein and your bicep just magically absorbs 20 grams of protein.
Like a one-to-one transfer.
Exactly. But the biological reality of how we break down and pool and actually utilize amino acids is just far more dynamic than that.
Right.
The idea that you need animal tissue to construct human tissue is just a severe underestimation of our metabolic flexibility.
Okay, let's get straight into that metabolic reality then, because we know the body requires all 9 essential amino acids to, trigger muscle protein synthesis.
Right, essential meaning your body can't make them on its own.
Exactly, you have to get them from food.
Mm.
And the old school bodybuilding narrative was always that plant sources were biochemically deficient, like they were just missing the necessary materials to get the job done.
And that is a profound mischaracterization. I mean, most single plant foods, whether we are talking about a grain of rice, a lentil, or a peanut, they actually contain all 9 essential amino acids.
Wait, really? All 9?
Yes, all 9. They're not missing entirely. The issue is simply one of proportion.
Okay, so they just have less of certain ones.
Exactly. A specific plant will typically run low in 1 or 2 specific amino acids. So rice, for instance, has all 9, but it has a very low concentration of an amino acid called lysine.
Got it.
And beans contain all 9 too, but they are bottlenecked by a really low amount of methionine.
Okay, that makes sense. It makes me think of like a graphic equalizer in audio production,
Oh, I like that.
right? Like you have all the frequencies present, but on the rice channel, the bass slider is pulled way, way down.
Yeah.
And then on the bean channel, the treble slider is pulled down. So if you listen to them in isolation, the track sounds a little hollow.
Right. It's lacking depth.
But if you play them over each other, the frequencies fill each other's gaps, and you get this full, rich spectrum of sound.
That is a brilliant way to visualize it. You are simply overlapping the biochemical profiles to create a complete spectrum.
That's so cool.
Yeah, and nutrition researchers, they actually measure this efficiency using a system called PDCAAS.
Okay, PDCAAS. What is that?
It stands for the Protein Digestibility Corrected Amino Acid Score.
Wow. Okay. That's a mouthful.
It is, yeah. But this score evaluates 2 things. First, the raw amino acid profile of the food.
Okay.
And second, how effectively the human gastrointestinal tract can actually break it down and absorb it into the bloodstream.
Okay, I hear you on the overlapping profiles and the scores, but let's be real for a second.
Sure.
Athletes and bodybuilders have been swearing by whey isolate and chicken breast for decades, specifically because of bioavailability.
Oh, absolutely.
So are we just coping by saying plants are equal? Or does the bioavailability genuinely match up on a gram-for-gram basis when you combine them?
Yeah.
Because, plants come with a lot of structural baggage.
You are hitting on the exact reason plants traditionally score lower on the PDCA scale in isolation. It isn't just the amino acid bottleneck we talked about.
Right.
It is the physical architecture of the plant itself.
Mm-hmm.
Animal protein is highly bioavailable because it just doesn't have fibrous cell walls.
Oh, so it's easier to break down.
Exactly. Plant proteins are locked inside these complex carbohydrate matrices. They contain fiber and compounds like phytates that can actually bind to proteins and actively inhibit your digestive enzymes.
So your body is working overtime just to get to the protein.
Right. So a raw plant protein is just fundamentally harder for your body to access.
Okay, but there's a workaround.
Yes. When you combine complementary plants like the rice and the beans and you prepare them properly through cooking or soaking or fermenting, you break down that matrix.
Oh, I see.
And when you do that, the resulting combined PDCAAS score shoots way up. It literally rivals eggs or dairy.
Wait, okay, but if my body has a bottleneck of lysine at breakfast because, let's say, I only ate oats,
Right.
doesn't that mean the muscle synthesis window just closes? I was always told you have to eat the rice and the beans on the exact same plate.
Oh, the same meal rule.
Yeah. Like, if I eat the rice at noon and the beans at 6, doesn't my body just waste the incomplete morning protein?
That is probably the most pervasive piece of outdated science in nutrition today.
Really? It's not true.
Not at all. The same meal combining rule originates from early 20th century research that just fundamentally misunderstood human metabolism.
Wow.
Yeah. The modern consensus, and this is backed by Harvard, the World Health Organization, the UN's Food and Agriculture Organization, they have entirely retired that rule.
That's huge. So what actually happens?
Your liver and your bloodstream, they maintain this free amino acid pool.
Okay, so it's essentially a biological construction site.
Yes.
Like, you don't need the delivery truck to drop off the drywall and the plumbing pipes and the electrical wire at the exact same hour.
Yes.
You just need all the materials dropped off on site by the end of the day. And as long as the materials are in the staging area, the cellular builders can do their job overnight.
The construction site analogy is perfectly accurate. Your body draws from this hepatic pool and replenishes it continuously.
So it's not a rush.
Not at all. If you eat a grain in the morning, those amino acids circulate and they just wait in the pool.
And then,
When you eat a legume in the evening, the missing methionine or lysine arrives, the profile is completed, and protein synthesis proceeds seamlessly.
what's fascinating here is how liberating that is. The pressure people feel to meticulously engineer every single plate, it's just completely divorced from how our physiology actually operates.
It really is. It takes so much stress out of eating.
It's almost frustrating how simple that is, considering how much money is spent on engineered protein supplements.
Oh, it's a massive industry.
Right. But obviously, traditional cultures weren't calculating PDCA scores or monitoring their hepatic amino acid pools.
Definitely not.
Yet, when we look at the historical data in the source material, they were building these exact complementary profiles.
They really were. Traditional diets are a masterclass in intuitive biochemistry.
It's amazing.
Across completely isolated global populations, we see the exact same agricultural and culinary patterns emerge. In the American South, it was cornbread paired with black-eyed peas.
Oh, yeah.
In Mesoamerica, it was corn tortillas and pinto beans. The Middle East paired hummus, which is chickpeas, a legume with pita, a wheat grain.
It's everywhere.
Italy gave us pasta e fagioli. That is literally wheat, pasta, and beans.
They were independently solving the lysine and methionine bottlenecks without microscopes.
Exactly.
They were optimizing for something else entirely, which kind of leads me to wonder what the actual biological feedback loop was.
Right. How did they know?
Yeah, if they didn't know they were completing an amino acid profile, what physical sensation told them they were getting it right? Like, did they just get lucky?
Well, if we connect this to the bigger picture, they optimized for satiety and sustained energy.
Okay, so just feeling full and strong.
Right. When you consume a complete amino acid profile, it triggers a cascade of hormonal responses. This includes satiety hormones that signal the brain that your nutritional requirements have been met.
So you actually feel satisfied.
Yes. Furthermore, a complete profile allows the body to efficiently produce ATP, which is our cellular energy currency,
Got it.
and it repairs micro tears in muscle tissue from manual labor. So generation after generation, populations simply noticed that eating the corn with the beans kept them working in the field significantly longer.
Without just collapsing from hunger.
Exactly, without debilitating hunger, compared to eating either food in isolation. The culinary traditions stuck because the physiological feedback was just undeniable.
The body absolutely knows what it needs. That is so cool.
Yeah, it really does.
But if this biological safety net is so robust, like if our liver is cooling amino acids and our traditions have already solved the puzzle, what does it look like when someone today actually fails to fill the pool?
That's a great question.
Because a lot of people go plant-based, they eat a huge volume of food, and they still end up feeling terrible.
Yeah, that happens a lot. So the clinical signs of an amino acid gap are often misdiagnosed as general fatigue or just aging.
People just think they're getting old.
Right. When someone removes meat but fails to introduce intentional plant variety, they inevitably deplete the pool. We see this constantly in clinical case studies.
Really?
Yeah. The sources highlight a classic example with a graphic designer named Sarah. She transitioned to a vegetarian diet for health reasons, but she relied almost entirely on pasta, bread, and cheese.
Which means she was overloading on wheat grains. So she was getting plenty of methionine, but basically starving her body of lysine.
Exactly. And the downstream effects were highly predictable. After a few months, she was exhausted during her evening runs, her recovery just plummeted, and she was experiencing ravenous hunger just an hour after eating a massive meal.
Because her body was sending out distress signals.
Yeah.
It didn't matter that her stomach was physically stretched full of pasta.
Mm.
On a cellular level, her body was screaming, "We are still missing the materials to repair this muscle tissue. Go find food."
That's exactly what was happening. She was eating adequate calories and even adequate total grams of protein on paper, but her biological construction site was stalled.
So what did she do?
Once she learned about the grain and legume dynamic, she didn't overhaul her whole life. She just started keeping cooked lentils and quinoa in her fridge and added mixed nuts to her daily snacks.
Simple fixes.
Very simple. By closing the lysine gap, her energy stabilized and the constant snacking ceased because her satiety hormones were finally being properly triggered.
Wow. Okay, so Sarah's story makes perfect sense from a purely mechanical standpoint, but the research also brings up Michael, a high school teacher and basketball coach.
Ah, yes. Micah's case is fascinating.
His story caught my eye because he was eating the right foods. Like, he was incorporating edamame and black beans, but his post-game recovery was still dragging. He initially just blamed it on turning 41.
Right, he thought it was just his age.
Yeah.
But Michael's case introduces a critical variable that completely upends the food as math paradigm, and that is systemic stress.
Got stress.
We assume that if we swallow a complete protein, we absorb a complete protein, but nutrient absorption is heavily modulated by the autonomic nervous system. Michael was incredibly stressed balancing grading papers, coaching, and just a chaotic schedule.
So even with the perfect overlapping amino acid profile sitting in his stomach, his body was essentially refusing to process it.
Yes. When you are under chronic stress, your body pumps out cortisol and adrenaline. You enter a sympathetic dominant state, fight or flight.
Right.
Biologically, if you are running from a predator, your body does not care about digesting black beans or repairing muscle tissue.
It's trying to keep you alive.
Exactly. It actively shunts blood flow away from the gastrointestinal tract and toward the extremities. Digestion requires a parasympathetic state, which is rest and digest.
Wow. And not only is the digestion shutting down, but isn't high cortisol actively catabolic?
It is.
Meaning it literally breaks down muscle tissue for quick energy rather than building it.
It is a total double-edged sword. Cortisol breaks down existing muscle for amino acids to convert into glucose for quick energy.
Yikes.
And simultaneously, it inhibits the digestive enzymes needed to extract new amino acids from the food you just ate.
So he was losing on both ends.
Exactly. For Michael, addressing his demanding schedule and regulating his nervous system was the missing metabolic key.
It really proves that health is not just about what is on the plate.
No, it's about the physiological state of the body receiving it. Once he managed his stress response, his digestion improved, the edamame and black beans were actually utilized, and his post-game soreness just vanished.
Here's where it gets really interesting, because that drastically shifts the perspective. We are obsessing over the exact gram count of our macros while eating lunch hunched over a laptop, firing off stressful emails, and wondering why we aren't absorbing our nutrients.
So common.
It really brings us back to the actionable side of this deep dive. I want to look at how we actually apply this without carrying a calculator or adding more stress to our lives.
Right, practical steps.
Because I'm thinking about decision fatigue here. A nurse working 12-hour shifts isn't going to calculate her lysine intake at 4 p.m.
Definitely not. Decision fatigue is the absolute enemy of sustainable nutrition. When the brain is tired, it defaults to the path of least resistance.
Which usually means refined carbohydrates from a vending machine.
Exactly. The most effective interventions are just environmental design. The research profiles Jennifer, a nurse who solved her afternoon energy, crashes entirely through batch cooking.
Oh, nice.
By preparing a large container of rice and a large container of lentils on Sunday, she completely bypassed the 4 p.m. decision-making process. The complementary pairing was just waiting for her.
It's engineering your environment so that the lazy choice is also the optimal choice.
That's a great way to put it.
And that actually brings me back to the peanut butter sandwich. Let's look at the mechanics of why a 2-minute pantry staple actually solves the biochemical bottleneck. Because most people view a PB&J as a desperation meal when the fridge is empty.
Oh, I know. But from a biochemical standpoint, a peanut butter sandwich on whole wheat bread is an elite, highly efficient pairing.
Really?
Yeah, peanuts are not actually nuts. They are legumes. So they bring the robust lysine profile that perfectly complements the methionine-heavy wheat grain in the bread. You are creating a complete, highly digestible amino acid profile in 2 minutes for pennies without turning on a stove.
That is the ultimate biological hack.
It really is.
And for those who want an even simpler anchor, the research highlights soy, tofu, edamame, and tempeh. They just bypass the combining rule entirely, don't they?
They do. Soy is unique in the plant kingdom. On the PDCAAS scale we talked about earlier, soy protein isolate score is a perfect 1.0.
Wow, so identical to beef or milk.
Exactly identical. The amino acid profile is naturally robust across the board, and the structural matrix of the soybean, especially when it's processed into tofu or fermented into tempeh, is highly digestible.
And that makes it so easy.
Yeah, if you want a foundational plant protein that requires zero thought about pairings, soy is your anchor.
Beyond the main meals, the sources suggest using visual cues to handle the gaps, like leaving a glass jar of mixed nuts and seeds on the kitchen counter, pumpkin seeds, sunflower seeds, walnuts.
Visual cues drive behavior. A jar of seeds on the counter turns mindless snacking into an intentional infusion of diverse amino acids.
And you are getting a massive secondary benefit there.
You are! Pumpkin and sunflower seeds are exceptionally high in dietary magnesium.
Which ties perfectly back into Michael's stress problem.
Yeah.
Magnesium is critical for regulating the nervous system, down-regulating cortisol, and improving sleep quality.
Exactly.
So the snack is not just providing the building blocks, it's actively preparing the nervous system to absorb them.
It creates a beautiful, positive biological feedback loop. And another vital architectural component the research emphasizes is adding a vegetable to every grain and legume pairing.
Okay, so not just a generic eat your greens platitude.
No, it directly impacts protein assimilation.
Wait, because of the microbiome.
Exactly. Earlier, we discussed how plant proteins are trapped inside complex fibrous matrices, which lowers their bioavailability.
Right.
Well, the specific types of fiber found in broccoli or spinach or bell peppers, they feed the bacteria in your gut microbiome.
Okay, I follow.
A robust, well-fed microbiome produces enzymes that help break down those stubborn plant cell walls, effectively increasing the PDCAA score of the meal in real time, right inside your digestive tract.
So the vegetables are literally the facilitators of the protein.
They are the facilitators, yes.
So the whole system works in concert.
Yeah.
But we also have to look at what disrupts this system. The sources offer a pretty clear warning about misattributing dietary failures.
Yeah, this is a big one.
People switch to a plant-based diet, they experience a massive energy crash, and they immediately blame the lack of animal protein.
And the misattribution usually comes down to refined carbohydrates and added sugar.
Not the protein at all.
Nope. When someone removes meat but replaces it with refined white pasta, white bread, and sugary snacks just to fill the caloric void, they subject themselves to violent blood sugar spikes and subsequent crashes.
Does that make sense?
The profound fatigue they feel at 2 p.m. is not a lysine deficiency, it is a hypoglycemic crash. But the narrative of the incomplete plant protein is so ingrained that they immediately assume the diet itself is fundamentally flawed.
It's the trap of relying on refined grains. When you strip the wheat germ and the bran away to make white flour, you aren't just losing fiber, you are losing a massive portion of the amino acids that were supposed to contribute to that hepatic pool.
Yes. You are left with pure energy but absolutely no structural building blocks.
Oh.
Maintaining that steady pool requires whole grains like oats, brown rice, quinoa that digest slowly and release their amino acids over hours rather than minutes.
Which is also why skipping meals, particularly breakfast, can be destabilizing.
Oh, highly destabilizing. It forces the body to play catch-up later in the day, often leading to overconsumption of less balanced foods when that hunger just becomes unmanageable.
Yeah, we've all been there. So what does this all mean? If we step back and look at the entire picture, the overlapping frequencies of lysine and methionine, the liver's amino acid pool, the historical wisdom of corn and beans, and the biological necessity of managing our cortisol, it basically boils down to the fact that you do not need to overcomplicate your meals to be healthy.
Not at all.
Health isn't a final destination you arrive at once you've engineered the perfect spreadsheet of macros. It's a direction.
Beautifully said.
It is chosen through small, daily awareness. Just eating a variety of whole foods across the day and managing the stress of the body receiving them does all the heavy lifting for you.
It really forces us to reevaluate our reliance on modern data. We have seen how our ancestors intuitively knew exactly how to combine foods for optimal tissue repair and sustained energy.
Yeah, they figured it out.
They didn't have PDCAAS charts or nutrient tracking apps. They simply listened to their body's satiety signals. They paid attention to what made them feel genuinely full, strong, and capable. And this raises an important question. What other modern, overly complicated nutritional rules are we currently stressing over that our bodies actually already know how to solve if we would just quiet down and listen to them?
That is a truly fascinating thought to leave on. The biological wisdom is already built into the system. We just have to get out of our own way and pay attention. Thank you so much for joining us on this deep dive. Keep listening to your body. Maybe go make yourself a peanut butter sandwich, and we'll catch you next time.